The TSMC bags up $11.6 billion CHIPS Act funding. TSMC and the U.S. Department of Commerce have finalized their previously announced preliminary agreement that TSMC should receive $6.6 billion of CHIPS Act money plus $500 billion in loans in a 25% tax credit in the sorry, that's euro. Euro. This is euro. 5 billion euro in loans and a 55 tax credit, a 25% tax credit on infrastructure capex to support the $65 billion investment in it is making the three fabs in Arizona. This is the largest foreign direct investment in a greenfield project in history of the United States, said the U.S. President Joe Biden. Pictured right, the first of TSMC's three facilities is on track to fully open early next year, which means that the first time in a decade, an American manufacturer plant will be producing the leading-edge chips used in our most advanced technologies. Entering this phase of the U.S. CHIPS Science Act marks a pivotal step in strengthening the semiconductor ecosystem in the United States, said TSMC CEO C.C. Wade features left. TSMC appreciated the continued collaboration with the customers and partners, local communities, and the U.S. government beginning in early 2020. So the signing of this agreement helps us to accelerate the development of the most advanced semiconductor manufacturing technology available in the U.S. Next article is Intel CEO optimistic about the CHIPS Act future after training text with J.D. Vance. So the Intel CEO Pat Gelsinger global GPU market is to hit the $100 billion in 2024. AI GPUs are leading the market. The graphics processing units GPUs are ubiquitously found in the many of the devices that we interact with on a daily basis. So in addition, GPUs are used for the AI and supercomputer workloads, and a high-end processor from the companies like AMD or NVIDIA can cost 10,000 to 3,000, $30,000 or more. The demand for these units is increasing rapidly as a result the revenue of GPU developers is growing, and this year the global GPU market is expected to exceed $98.5 billion according to the John Patty research. Currently, there are 20 companies and 7 IP vendors developing discrete and integrated and embedded GPUs, JPR reports. Most of these graphics processor are entry-level integrated GPUs, and only a few companies develop standalone GPUs for gamers, including the best graphic cards. However, most of the revenue is earned from the GPUs that are used for the graphics. Sales of the AI and HPC GPUs totals only several millions units per year, but since they are sold for tens of thousands of dollars per unit, they are bringing in tens of billions for NVIDIA and billions of AMD. In just 2 quarters of fiscal 2025, NVIDIA earned $42 billion from its AI and HPC GPUs, and for the whole year, sales of its compute GPUs could exceed $9 billion. The AMD expected the sales of each AI GPUs to exceed $3 billion. It is hard to estimate the revenues of the companies like Bayer and Texas MetaX, but we doubt their compute GPU sales come close to those of AMD. The graphics GPU units have become ubiquitous, can be found in most every industrial and scientific commercial and customer product made today, said Dr. John Patty, the president of the John Patty Research. Some market segments like AI have a great headline because of their rapid growth and high average selling price (ASP), but they are low volume and compared to other market segments. However, while the market for AI GPU is low volume compared to other segments, newcomers to the GPU market, particularly those from China, are focused on the data center AI GPUs rather than the GPU for gaming. So of course, these companies face restriction from US government, and which does not want China to access leading edge AI technology. But apparently they are willing to take the risks, and the potential of the AI market is very significantly. The Samsung Galaxy 25 may offer a superior gaming experience with this Qualcomm tech. The key takeaways: Samsung is seemingly working on a game assist feature to improve game performance. It will upscale the games to 120 Hz for a better experience while generating less heat. The feature might rely on the Qualcomm's Adreno Frame Motion Engine 2.0 tech for framing interpolation and upscaling. If the leaks are believed, the Samsung next flagship, the Galaxy S25 series will debut in the late January 2025. So the Samsung in some upcoming flagship will also coincide with the stable release of the Android 15-based One UI 7, as previously detailed by the company. Multi-hands video have detailed various One UI 7 features. A new leak now hints on a game assist feature that will help improve the game performance on Galaxy phone using upscaling. The Samsung phones ships with a game booster which prioritizes gaming the performance and provides access to the several handy tools. So the higher-rated new game assist feature Samsung wants to deliver even better gaming experience on its devices. As a screenshot shared by leaker John Kolosever shows via Android abilities, so the game assist will create a more enjoyable gameplay experience with the game assistance. So it will achieve this by upscaling the game's limited 60 Hz to 120 Hz. So there will be several other performance optimizations, ensuring your Galaxy phone delivers better performance while generating less heat, allowing for longer gaming sessions. Apparently, Game Assist will rely on Qualcomm's Adreno Frame Motion Engine 2.0 AFME for frame interpolation and upscaling. The chipmaker says that provide realistic detail by generating high quality scene and doubling the frame rate while maintaining the same power consumption. More Android games need to support high refresh rate display. Despite Android phones with high refresh rate displays being around for a few years, many popular Android games don't support them. Instead, they are run at the 60 Hz or lower, leading to a less smooth experience. Samsung might be looking to solve these problems using Game Assist. With the Snapdragon 8 Gen 3 chip also supports AFME 2.0, Samsung might limit the Game Assist to its coming Snapdragon 8 Elite powered Galaxy 25 series. If the feature works at a Qualcomm promise, it could make the Samsung Galaxy 25 among the best game phones. The Game Assist should be another key One UI 7 feature that could help it stand out from other Android games. All signs point to Samsung working on a big revamp of One UI, focusing on an iPhone-like smoothness and a one-handed use for the better experience. Yeah. Next is Forbes Travel Guide 25 most anticipated hotel opening of 2025. Is it? Why? I'm sorry. The NVIDIA accelerated Google Quantum's AI design with quantum physics simulation. NVIDIA and Google Quantum AI joined our NVIDIA. It is working with the Google Quantum AI to accelerate the design of its next generation quantum computing devices using simulations powered by NVIDIA. The Google Quantum AI is using the hybrid Qualcomm classic computing platform and the NVIDIA EOS supercomputer to simulate the physics of the quantum processors. This will help overcome the current limitation of quantum computing hardware, which can run only a certain number of quantum operations before computation must cease to do what the researchers call a noise. The development of the commercial useful quantum computers is the only possible if we can scale up the quantum hardware while keeping noise in check, said Geoffrey Weider, research scientist from Google Qualcomm AI, in a statement. Using NVIDIA accelerated computing, we are exploring the noise implication of the increasingly large quantum chip designs. Understanding noise in a quantum hardware design requires complex dynamic simulation capable of fully capturing how qubits within a quantum processor interact with their environment. These simulations have traditionally been prohibitively computationally sensitive to pursue using the CUDA and Q platform. However, Google can employ the 1024 NVIDIA H100 Tensor Core GPUs at NVIDIA use supercomputer to perform one of the world's largest and fastest dynamic simulation of quantum devices at a fraction of the cost. AI supercomputing power will be helpful to quantum computing success, said the team co-staff director of the Qualcomm Quantum and HPC at NVIDIA in a statement. Google use of the CUDA-Q platform demonstrates the center of the role GPU accelerated simulations having advanced Qualcomm computing to help real-world problems. With CUDA-Q and H100 GPUs, and Google can perform comprehensive and realistic simulations of devices containing fully qubits and large performance simulations of this kind. These simulation techniques provided by the CUDA-Q has been noisy simulations that have been taken we can run in minutes. The software powering these accelerated dynamic simulations will be publicly available in the CUDA-Q platforms, allowing the quantum hardware engineers to rapidly scale their system designs. NVIDIA announced the NVIDIA Omniverse Blueprint, a technology that enables industry software developers build digital twins with realistic time physics. The title is NVIDIA Unveil Omniverse Real-Time Physics Digital Twin. If enables computer-aided engineering customers in aerospace, automotive, and manufacturers, energy, and other industry create digital twins with a real-time interactive. One example of this that is a virtual wind tunnel that car designers can use to simulate wind moving over a simulated car. NVIDIA made the announcement at the SC24 supercomputer event. The software developed as Altair, ANSYS, Cadence, and Siemens can use the reference workflow, which includes NVIDIA acceleration libraries, physics, AI frameworks, and interactively physically based rendering to achieve 1,200 times faster simulation, the real-time visualization. This helps their customers to drive down development costs and energy usage while getting to market faster. We built the Omniverse so that everything can have a digital twin, said Jensen Huang, is the CEO of NVIDIA in a statement. Omniverse blueprints are also reference pipelines that connect NVIDIA Omniverse with AI technologies, enabling the leading CAE software developers to build groundbreaking digital twin as a workflow that will transfer industrial digitalization from design and manufacturing to operations for the world's largest industries. One of the first applications of the blueprints is computational fluid dynamics simulations, a critical step to virtually explore, test, and refine the design of cars, airplanes, and ships, and many other products. Traditional engineering workflow, from physics simulation to visualization and design optimization, can take weeks to even months to complete. In an industry first, NVIDIA Luminary Cloud demonstration at the CSISC24, a virtual wind tunnel that allows users to simulate and visualize the fluid dynamics in real time, interactive speed, and when even changing the vehicle model inside the tunnel, unifying three pillars of the NVIDIA dev tech. The building a real-time physics between the digital twin requires two fundamental capabilities: real-time physics server performance and real-time visualization of the large-scale data sets. The Omnibus Blueprint achieved these by bringing together NVIDIA CUDA-X libraries to accelerate the servers, and the NVIDIA Modular Physics AI Frame to train and deploy the models and to generate flow field, and NVIDIA Omnibus Application Programming Interface for 3D data interpolatable and a real-time RTX-enabled visualization. Developers can integrate the blueprints as individual element or in its entirety into their existing tools. So ANSYS is the first customers to adopt the Omnibus Blueprint, applying it to ANSYS Fluent Fluid Simulation software to enable accelerated computational fluid dynamics and simulation. ANSYS can Fluent that Texas Advanced Computing the center on a 320 NVIDIA GH200 Grace Hopper super chips. A 2.5 billion cell automotive simulation was completed in just over 6 hours. That would have taken nearly a month running a 2048 x86 CPU cores and significantly enhanced the feasibility of online high fidelity CFD analysis and establishing a new industry benchmarks. By integrating NVIDIA Omnibus Blueprint with the ANSYS software, we are enabling our customers to tackle increasingly complex and detailed simulations more quickly and accurately, said Jay Gopal, CEO of ANSYS in a statement. Our collaboration is pushing the boundary of engineering and design across multiple industries. The Luminary Cloud is also adopting the blueprint. The company's new simulation AI model, built on NVIDIA Modulus, learned the relationship between the airflow field and the car geometry based on the training data generated by the HS GPU accelerated CFD server. The model runs simulation orders of the magnitude faster than the server itself, enabling real-time aerodynamic flow simulation that are visualized using the Omnibus APIs. Altair Beyond Math, Cadence, and Hexagon, Neural Concept, and Gmans and SimScale and Train technologies are also exploring the adoption of the Omnibus Blueprint into their own applications. The Omnibus Blueprint can be run on all leading cloud platforms, including Amazon and Web Service, Google Cloud, and Microsoft Azure. It is also available in the NVIDIA DGX Cloud. Rescale, a cloud-based platform that helps organizations accelerate scientific engineering breakthroughs, is using the NVIDIA Omnibus Blueprint to enable organizations to train and deploy custom AI models in just a few clicks. The Rescale platform automates the full application to hardware stack and can be run across any cloud service provider. Organizations can generate training data using any simulation server, prepare and train and deploy the AI models, run interference prediction and individualize and optimize the model. The company interested to learn a lot more about NVIDIA Omnibus Blueprint for real-time computer-aided engineering digital twins can sign up for early access. TSMC said 1.6 nanometer model to be production ready in late 2026. The roadmap remains on track. No, A16 is not delayed, said TSMC. The TSMC's plan for the next couple of the years remain largely unchanged as the company is ready to mass produce chips in H and 2 nanometer class, manufacturing technology starting in late 2025 and A16, 1.6 nanometer class, fabrication process in late 2026. The the company announced that its Open Innovation Platform OIP 2024 conference here in Amsterdam in Netherlands. The roadmap you see here is pretty much the same. Actually, it is the same technology roadmap that I think you saw during the technology symposium 6 months ago, said Dan Kochapacharin, head of design and infrastructure management at TSMC. We have N2, N2P, which is coming to production next year, the next year after, and they are followed by the A16. The road followed the slide showing the A16 after N2P and N2X was somewhat confusing to me. On the one hand, the slide TSMC shared is very similar to one it presented back in May. On the other hand, the message sent back then was that A16 and N2P and N2X would be available around the same time. I asked TSMC's head to a PR department to clarify that indeed all of these process technologies are slated to be ready for high volume manufacturers HVM in late 2026. This is of course as far as TSMC would go in official comment. The company will not pre-announce product for its alpha customers that are set to arrive in the market sometimes in 2027. So let us speculate about the positioning of these manufacturing processes. Technically, N2, N2P, N2X, and A16 share many similarity. They are all based on nanosheet gate all-around GAA transistors. The N2 series uses super high performance metal sincerity metal SHPMIM capacitor to reduce transistor via resistance to improve performance efficiency, where A16 uses backside power delivery network BSPDN to improve it even further. The A16 is basically N2P with a super power rail, which is our innovative backside power delivery network, said Dan Kochapacharin. While generally BSPDN enables high performance and a better power efficiency, there is no free lunch here, as noted by the Ken Wang, TSMC Director of Design Solution Exploration. The backside power delivery also adds thermal issues that have been migrated. For now, the PSPD and its current implementation is the best fit for data center, grade AI-aimed processors, a market segment for that TSMC aims at with its A16 for now. Next article is Qualcomm sets up a smartphone or generative AI with the Snapdragon AI 8 Elite. At its recent flagship launch event, the Snapdragon Summit, Qualcomm brought the Orion CPU to its smartphone platform, building on the first generation Orion CPU that was first introduced last year with the company's AI PC chip. The company announced its latest generation mobile SoC for smartphone and the Snapdragon 8 Elite. The new SoC uses the second generation Orion CPUs clocked at the maximum frequency of 4.32 GHz combined with 24 MB of the total CPU cache and to 5.3 GHz LPDDR5X memory. Compared with the previous generation, the new CPU delivers a 45% increase in CPU performance and 44% improvement in power consumption, according to the Qualcomm. In a departure from its previous naming conventions, which would have made the Snapdragon 8 Gen 4, Qualcomm carried over the Elite branding from the X Elite. As became apparent of the other CPU SoCs announced at the event, Qualcomm is using the Elite branding to denote the SoC powered by its customer Orion CPUs. The two cores in one. Performance and power consumption are conflicting metrics that are often traded off with each other. Delivering improvement for both fronts is not an easy task. For the Orion CPU, this was accomplished by mainly with the SoC microarchitecture consists of the 2 prime cores and 60 performance cores. Some might ask, is this just the remaining of the big little microarchitecture where Qualcomm is just calling the performance cores, prime cores, and efficiency cores, and performance cores? While on the surface that might seem like the case, upon closer inspection, there is one key difference that makes this not a simply market exercise, but a true engineering accomplishment. And this microarchitecture, the 2 prime cores to provide maximum performance at a higher or power profile. In that sense, it is taking on the role of the big core in a big little microarchitecture. The key differentiator comes in what the Orion CPU's performance cores are capable of. They are basically both a traditional performance core and a efficiency core enabled by the dynamic range of the Orion CPU's performance. So the cores are processing versus power curves. A core is typically categorized as a performance and efficiency based on the types of workloads it can support with the processing power it can bring to bear and the power it requires to do so. Based on its internal design microarchitecture, these cores have defined a dynamic range in which processing power can be scaled up or down by controlling its power consumption. Efficiency cores are typically lower power and lower complexity cores, and the complexity cores, and as such are limited with how much it can scale up in terms of processing capability. On the other hand, the typical performance cores are designed for as higher processing capabilities, but at the cost of a higher performance consumption profile. Traditionally, while they are more than powerful enough to process workloads that efficiency cores can support, it doesn't make sense to use them in that manner given the cost in higher performance consumption when dealing with lighter compute tasks. What makes the Orion CPU different is that performance cores are both traditional performance cores and efficiency cores in one. The range in which it can scale in terms of processing and power covers the lower ranges like efficiency core. However, the microarchitecture design allows to scale up to its power consumption, thus its processing performance adjusts typical performance core workloads. Thus, Jena Orion CPU has 6 of these performance cores. When paired with the 2 what Qualcomm is calling is even more capable prime core clocked at up to 4.32 gigahertz. The company is confident that its latest SoC has more than enough horsepower while ensuring the increased battery life for the next evolution of AI smartphones. This was further demonstrated at the event, and Qualcomm benchmarked the smartphone SoC against the AI PC SoCs from their competition, and based on their numbers, Qualcomm won. The new CPU is just one of the design elements that Qualcomm is hoping will set the stage of the agentic AI smartphones. The evaluation to the agentic AI. Currently, the generative AI applications are primarily transactional and responsive in nature, and this is rapidly evolving into what many are calling the agentic AI, which aims to introduce more autonomy, sophisticated reasoning, and multi-step problem solving using AI agent. In this paradigm, the agentic AI utilizes input from as many one-device sensors as possible, coupled with other conceptual information and learned behavior to not only respond to human queries but to provide a recommendation and eventually autonomous decision making. Along with the the new Orion CPU, Qualcomm has introduced features in the Snapdragon 8 Elite that build toward the agentic AI capabilities. So two such improvements are enhanced multimodal input capabilities and direct NPU access to image sensor feed. The multimodal input to the Gen AI inference models got critical in allowing agentic AI models to receive as much context at a given snapshot in time as possible, just like humans will take input from multiple senses at the same time to process the world around them. This capability is not simply just being able to ingest audio and video image and a sensor or video input, but it is also cognitive ability to stitch all of the input together to provide a complete context upon which the AI model can act. So enabling the NPU to have direct access to the image sensor feed is dramatically enhanced the ability for the camera to be used as not just something that captures pixels, but as a real-time sensor that AI models can efficiently use. The providing a contextual digital information on the analog world in which the device is operating. This goes beyond the object detection and classification. It also extends to a time of the flight sensing, depth perception, and other information similar to how humans utilize vision. Depending on the type of the image sensor being used, this capability can be expanded past what humans can perceive by providing information outside the visual spectrum into the infrared and ultraviolet ranges. Are we there yet? Agentic AI is not quite here yet and will require further enhancements in Gen AI autonomy, sophisticated reasoning, and multi-step problem solving. These enhancements will need further development on multiple fronts, from processing capabilities and memory performance, and improved multimodal sensor inputs and advanced in fine-tuning the AI models. However, the capabilities that Qualcomm has introduced in the Snapdragon 8 Elite, the first essential steps down the evolutionary paths have been taken, and it will only be a matter of time before our smartphones truly become a person assistants that not only provide us with information, but can act as an agent on our behalf. Okay. Yeah, I read several articles. Last one was Qualcomm sets up the smartphone for agentic AI with the Snapdragon 8 Elite. Thank you for your time. See you next time.